All right, so we are in chapter 7 now. So about halfway through, a little over halfway through. And so in chapter 7, we're dealing with properties of the normal distribution in this first section. So the normal probability distribution. We've already talked about it previously when we did the empirical rule, but now we're going to get a little bit more in depth with it. In this section, they talk about some different distributions, the uniform probability distribution, but mostly we're going to be looking at that bell-shaped curve. So let's look at a few problems from this section. So in number 3, it says the random number generator in calculators randomly generates number between 0 and 1. So the random variable x, the number generated, follows a uniform probability distribution. That's because each number has an equivalent chance of being picked. So that's why we have a uniform distribution. So getting something between 0.2 has the same probability of getting something between 0.8 and 1. So that's why it's a uniform distribution. So if we're trying to pick the graph that would represent this, we're going from 0 to 1. The probability of each one occurring. So let's look at this. So we want to go from 0 to 1. I like the increments of 0.2 on all of these. Now the density they have is 0.8 versus a 1. So I think we would go with the density. We could look at the probability of being picked. 1 would be more appropriate. Getting a number between 0.26 and 0.8. Well, the difference between that, 0.26 and 0.8, since the probabilities have to add up to 1, we see that the difference is 0.54 if we subtract those, 0.8 and 0.26. And so that's actually the probability, since everything has an equal chance between 0 and 1, then the probability is going to be 0.54 that it's in between there. So it's just subtracting those numbers that we're getting. And greater than 0.82, well, again, it goes up to 1, so we'd get a nice 0.18. So the probabilities have to add up to 1. It's equal throughout. And so dealing with a uniform distribution, it's a very nice rectangular shaped distribution. And not too bad to compute those values. Going to look at number 6 now. And so it's dealing more with that normal distribution. And it just wants to get an idea of the picture. So a normal curve with a mean of 68 and a standard deviation of 18. Well, we'll need to find a mean of 68, right, and a standard deviation of 18. Well, that one has 68, but it goes up to 86. Is that 18 more and 18 less? And so that gives us plus or minus 1 standard deviation. None of these have the right values. The mean needs to be in the center. And so just getting a visualization of what's going on. So in that case, A would have been our correct answer. And then looking a little bit more complex one, and number 8 from section 1. We are dealing with, looking at a graph and helping to interpret what it means. So we need to be able to interpret things, absolutely. So here's something, the mean is, I think that's at 255. And we're looking at 245 to the left. So provide one interpretation of the area. So it was 266, sorry. A standard deviation of 16 days. The area to the left of x equals 2.45, or 245, is 0.0947. So that's what that shaded in region is. So provide 2 interpretations. One interpretation of the area. Select the correct choice, fill in the... So the portion of human pregnancy that less than, and we could go ahead and say 245 days, the proportion is that value, 0.0947. Now, that is 1, right? We also could say that the portion of pregnancy that lasts more than 245 days is 1 minus that, right? That would be another interpretation. One is that it's 9% to the left or 91% to the right. So different ways that you can look at that. So let's check this answer. So a second would that last more than, right? And so we would just have to do 1 minus this number because the total is 100%. We get 0.9053 would be that right side. So we first gave everything to the left. Now we gave everything to the right. Oh, let's see what I did wrong. Probability that a randomly selected human pregnancy lasts more than 245 days is, let's see if I did my math wrong, 1 minus 0.0947. Oh, sorry. We're dealing with probabilities. We're still looking at the shaded area. So I would agree. So whether they use proportion or probability, we're going to get the same thing. So I was doing a little bit more than what they were asked. It would be a different interpretation, though. So again, proportion and probability, you're looking at the same thing. Of the shaded area, maybe is what they're inferring. So now we're looking in between 230 and 250, and they tell us what the area is, right? So in future sections, we're going to be finding the area between things, or to the left on these non-magical, exactly 1 standard deviation above or below. And so currently in this section, we're just interpreting